Today we are going to relearn that we know the things that we know about common denominator. So first of all, we have a fraction over here, and this is what represents a fraction. First you have a numerator, and that goes on top of the fraction, and that says the numerator is the number of pieces that you are currently considering. So you're thinking about this number of pieces out of, brings us the denominator. It's the number of equally sliced pieces that the whole is cut into. So let's say I have 5 candies and I have 8 other candies. And 5 candies are red and the other ones are the total colors together. So I'm considering only those 5 red ones. And then also that since in this the example that we're going to be doing today is that our units that we're thinking of are going to be in cookies. And we're only thinking of one cookie as one whole. So out of this cookie, we're going to break it into pieces, and that's going to represent our fraction. And also, again, pieces are the equally sized of parts in a whole. So today, we're going to represent that we can do 3/4 minus 5/7 by breaking this down and having the same number of parts, and the same number of same size parts within the whole. So this is one whole cookie, even though it's not round like a cookie, it's a cookie. This is one whole cookie, this is another whole cookie. And right now, we have, let's say like 3/4 of our cookies burnt, and that's why we have it shaded. So, thus we have 3/4 right here, and then I drew like little lines that separate it out of 1, 2, 3, out of 4. So 3/4 of our cookies burnt, and down here, we're gonna have another whole cookie, and we have 1, 2, 3, 4, 5 out of 7. So the numerator, remember, is 5, denominator is 7, and the whole is this whole one cookie. Same thing up here, numerator is 3, denominator is 4, and the whole is the whole cookie. So when we go to equate this back to the mathematical sense, we're trying to do 3/4 minus 5/7. We cannot do that because we do not have the same sized pieces or same sized like parts in this whole. This one has 7, this one has 4. We can't do that. So we have to think about how we can do that. So we need to add 7 more, not slices, or we need to make this the 4 parts to equate to equal to this one down here. So we add 7 more lines up here. So when we have 4, I'm just going to go across. I have 1 line, 2 line, 3, so 1, 2, 3, 4, 5, and 6, and 7. Alright, so we have, let's make sure I have all these right. 1, 2, so 1, 2, 3, 4, 5, 6, 7. Perfect. So now that I've cut all of these pieces into the whole, this number on the bottom is going to change because I no longer just have 4 sections that are the equally sliced pieces that the whole is cut into. I now have, if I add these up, 1, 2, 3, 4, and then 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 4, out of 28 total. If I were to add up all of these new little sections that I have made, or parts, equally sized parts that I have made, that represent the denominator. So I'm going to put this one down here just in better representation. I'm going to do the same thing down here. Since I had added 7 lines to this one, I need to add 4 lines down here to make it equal to 28 as well. So we're going to do 1, 3, alright. We're going to imagine those are perfect lines. So I come back here again, and I make sure, hey, do I have 28 in total? And of course, I did count these up here as well. They're part of the 28. So I count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 6. And altogether, I do have 28 as well. So we can bring the 28 over here, since now we have made equal parts within the whole. We still have one whole cookie, but we have made equal parts within the whole. And that's pieces, equally sized parts in a whole. So these are the number of pieces we have. So we can go back and say, all right, so this number is no longer just 3 because I've made all of these more parts. We can come up, or we can have a student even come up, and they can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. They have 21 shaded parts now. So we are considering 21 pieces out of our denominator, which is 28, and our whole, which is 1. So we're considering now 21. Awesome. And then we come over here, and we're we're going to count, obviously, just do the same exact thing because we no longer have 5 in the numerator because we have all of these new equally sized pieces that we've made. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20! Perfect. Now, since we already have the basic laws of arithmetic down, we know that 21, since we have, I'm going to go back to this. Since we have the same equally sliced pieces that the whole is cut into, we don't have to worry about the bottoms anymore because they're the same, and we just have to figure out the difference. So we take our new number in our numerator, 21, minus our new number in the numerator over there, and we equal 1 over 28 that we have. And that's what we would do. So we're taking one whole minus another whole of cookies, and we're still trying to find out the section that we have. Okay. All right. So back to what exactly our end number means now, because we've got 21 pieces that we have shaded out of here, out of the whole of 28, and we have 20 pieces that we have shaded out of here, out of the whole of 28, and those are equally sized pieces also. So when we take this bigger number that we got 21, this section that we have shaded, and we're minusing or subtracting, taking away the 20 over here that we've shaded, exactly the left shaded parts that we have are 1. So we have one little shaded part left over the 28 of the equally sliced pieces the whole is cut into. So you have one shaded part, which is the numerator, left over the whole of the equally sliced pieces. And also, this is how much you have out of the whole. So you have 1 over 28. We have one little burnt section of the 28th of your whole cookie left.